And because when we talk about particle astrophysics, it's extremely important to understand that particle astrophysics is sensitive to various energy scales. The astrophysics that you probe is different at different energy scales, and the detection method that you employ is also different for different energy scales and regimes. So you really have to pick sort of kind of where you want to be. Not that you have to be super specific, because you could basically operate in a range of energies, as do many of these experiments. But this is to show you, broadly speaking, where all the experiments are in the energy scales. There's Baji, also investigating the energy scales. And this is to show you kind of where everything fits. And this is also to show you, like, if you're doing Anita, for example, which is over here. The Anita experiment is over here. That's going to be complementary to something that is over here. So the neutrinos and the physics that ice cube would be sensitive to is going to be different. And ice cube is a different kind of probe than would be Anita, just because ice cube is kind of over here in the energy regime and Anita is over there. Or look at this, Dune is all the way over here. So what Dune is able to do is going to be completely different to where Anita is. So this is very important to understand, that you're not trying to do everything. You acknowledge all the other experiments and all the other people who work on all the other things. And that way, you're also motivating your own case of where you are working, so that you don't have to do everything. So you acknowledge everybody in the field so that you can do your thing, and you can say, well, those other people are doing those other things. So that's another way of looking at this, okay? Okay, I talked too much. I have to take a little bit of a break and drink some tea. Continue to study this plot, and we will continue the discussion in just a second, also when my phone has more charge. So here it is.